Okay, so if you look at sections 353 and 354, and this is again outside of your reaction engineering, but it ties into a kind of problem you can get on the exam, just specifically for the kinetic section. The general reversible reaction again is of this form, and chemical equilibrium. At chemical equilibrium, you know that the rate of the forward reaction is equal to the rate of the reverse reaction. And when you're at equilibrium, you can find this K sub C value. This is the equilibrium constant. And K sub C is dependent on the concentrations. And when I say concentrations, I mean molar concentrations throughout these slides. Molar concentrations of your products to their respective stoichiometric coefficient power over the reactants to their respective stoichiometric coefficient here. And this K sub C can also be represented as K sub P if you're dealing with all gases, right? If you're dealing with all gases, you're looking at partial pressures instead of molar concentrations. So in this situation, it's your partial pressure of C to the C power, partial pressure of D to the D power, over partial pressure of A to the A power, times partial pressure B to the B power. So these are both in this section, I believe. So you don't need to memorize these. But these are the ones you don't need to know. What you need to know is this relationship here, and this is in your reference handbook again, that you can determine the K sub P or K sub C using this formula. So they could ask a question there, and you just need to know where that formula is. In this case, N is equal to C plus D minus A plus B. So what that means is, if you're looking at this standard form here, it's C plus D minus A plus B. But if I had another product E here, right, then it would be C plus D plus E minus A plus B. So make sure you don't just take that literally. You're looking at the equation you're actually given on the exam, the reaction. So this is something they can ask as an easy question here. But the more complicated question they can ask is to find this KEQ value. KEQ is another sort of K constant, and it's not dependent on molar concentration, and it's not dependent on partial pressures. It's actually dependent on molar fractions. And when I say molar fraction, that means if I have 5 moles of A and 4 moles of B in a system, the molar fraction of A is equal to 5 over 9, because it's 5 moles of A over the total number of moles. So here, X sub letter is the mole fraction of each component. That's not to be confused with this other X known as the extent of reaction. This value is always less than 1 and greater than 0, actually. This is always 0 to 1. So if you can add that to your notes, I should change this to say from 0 to 1, not just less than 1. So this extent of reaction is always from 0 to 1. It represents the conversion of your reactants.